So based on the statistics of this assignment, we have decided to create a program for you, Dr. Hana, and also for Puan Maziani to try and key in the data and to essentially mark our assignment scores for your assignment and also for her assignment later in the semester. Once you have keyed in all the scores, you're able to check individual students' data as well as statistics of all the students, which we will get to later, all in one place. And not only that, the students and also the public are able to access their own scores and also to look at the said statistic as well. So the purpose of this assignment is to make sure that both you and Puan Maziani are able to have an organized system in keeping track and also keying in all the students' data based on how they perform. Also, you are able to do sort of a post-mortem based on their results and see the grade distribution, their improvement throughout the semesters and so on and so forth through the statistical, analytical data which we will provide later. Not only that, the students can be able to do the same thing as well, and they do not have to refer to multiple sheets of e-learn platforms to be able to access the said data. And also, we have created an encryption system which allows both the lecturers to key in their own password and also username when you first enter. So there'll be like a signing up system so that the rest of whoever, the general public, will not be able to access your part of the program that easily. So what you will have to do is you have to key in your own username and password at the beginning, and the next time you have to access it, you also need to key in the same username and password so that you will be able to access it in return.
So in accordance to the requirements of the assignment, we've built the program in an object-oriented way. The first one is encapsulation. It describes the bundling of all the data and methods together. So it's like a class in C++. So in our program, we have four types of classes, which are data, results, students, and USM candidate. And each of them have their own specific information. For example, for USM candidate, they have metric number and also necessary methods such as set metric and get metric. Moving on, we have data abstraction is to provide only the necessary details publicly to the user and hide the unnecessary one. And for example, in the student, you have total score, and the total score will be calculated internally and it won't be exposed to the public, so it can not be easily edited. We have also included the third concept of OOP, which is inheritance, where class can be derived from based on another class object. So in our program, we have student class and USM candidate class. Student class is derived from USM candidate because student is like the subset of USM candidate in our program. And using this method, the methods in the student are able to access the variable inside USM candidates, like for example, the metric number. And we can extend this to other type of candidate like UTM, etc. So moving on to the specification of requirements, which includes the input, process, output, constraint, and assumption of our program. I'll go through this very briefly. So the first thing the program will ask is the user that is accessing the program. Is it the lecturer or the public? And if it's the lecturer, they will need to sign up for their username and password to be used later. So the process includes processes that we use in our program, such as calculating the grade distribution, finding the student, accessing the database, and so on and so forth. Moving on, we have the output, which is what I just explained right now, and then the constraints. The constraints are that the user accessing the lecturer account must input the correct username and password if they have already signed up, and the metric number must exist, and the input should be valid. And the two lecturers are Dr. Hana and Puan Maziani. Hopefully, there's no third lecturer. One group only consists of 2 or 3 members. So this is the UML diagram for our program. As you can see, it includes the data, results, student, USM, these 4 classes in the diagram. And you can see the arrows, the 3 arrows right here, which These arrows and this arrow represents inheritance, where data inherit results, and student inherits USM candidate. And we also use composition, which are right here, this arrow. So as you can see in the pirate variable, there is the total results, which uses this class, and we link them by composition. And we also have the friend function right here. It is a calculate total scores and print array. It is implemented later in the main. As you can see, the print array and calculate total scores are implemented right here. And we've included all the functions, including the operators, inside this UML diagram.
So now let's take a look at the login system and also the assignment data system. Alright, so as you can see here, I'm accessing, let's say I am Dr. Hannah and I'm accessing the program for the first time. So you can see I'll press key in results for Dr. Hannah. You can see that you have not yet set a username and password, which you can set it now. So let's say your username is Dr. Alright, and also this will confirm your username and also enter your password. So let me just put a random password. Alright, so please confirm your password again, just like how normally it will do, just in case. And if you want to confirm password, just press yes, and then there will be a fetching data, something like that, which takes quite a short while, which everything is done already. So now we press continue. Alright, so do you want to key in scores, view scores, and also compare scores, which I'll let Ying Shen to explain this part.
A very good day, my name is Ying Shen, and now I am going to explain what this program has to offer to the lecturers. So after logging in as a lecturer, the program will prompt you to key in score, view score, or compare score. To key in score, you pick number 1. So for now, we'll pick number 1 as the score, and now it will prompt the lecturer to enter the number of students per group, which means in the same group, how many students. And since the limitation of this assignment CPT113 is 2 to 3 students, if we enter the number 4, it will prompt you to enter a valid number. So let's say if in the same group we have 3 students, these 3 students are of the same group. So for now, we just enter 3 as the total number of students per group. So the first students and the third students, let's say if we enter a wrong metric number, let's say any number will do. So it will prompt you to enter a valid metric number of student 3. So let's say student 3. Now it prompts the lecturer to enter the program completeness of students in current group. So this is one of the aspects of assignment that the lecturers are required to grade. It will prompt you to enter 0 until 10. So let's say all of the students in this group, they score full marks. So let's say we enter. After keying in all the scores, this program will prompt lecturer to enter Y to continue. And the same thing happens again. It prompts the lecturer to pick an option. So let's say now we want to view the score of the 3 students just now. So let's say 3 students per group, the same metric number. So after we enter the metric number of each student in the same group, it will display all the scores of these students. Now we want to continue again. We proceed to the third option, which is comparing the scores. So for comparing the score, it works a little different from the previous two, because let's say we enter 3, now the prompt is different. It prompts the lecturer to enter the number of students that they want to compare. So in this case, you can enter any number you want, but our limitation is that you can only pick a range of students from 2 until 20, because let's be honest, nobody want to enter that many metric number in a row. We want to compare the students of 5. First student metric number is 1.7, 627. And let's say we press an invalid metric number. Again, it will prompt you to enter a valid metric number. So as you can see, these 3 students at the very bottom are the one that we picked as students of the same group just now. So they all have the same total score. But keep in mind that the lecturer can choose any student she wants, no matter what group are they from. They can be from different groups. Like these two, they are from different groups. How this mechanism works is that we use bubble sort to compare and swap between student objects in a dynamic array. So that is how we arrange them from the lowest to the highest score by using the bubble sort technique. We want to continue, we just press Y. After that, the same prompt happens again. So for now, we want to key in score 1. So after keying in the metric number, we can enter the score. So 5, 3, 0. So let's say you enter 11. The limitation is that you can only enter a range of 0 until 10. So if you enter anything that is out of range, like 11, it will prompt you to enter a valid score between 0 and 10. Now we enter 5 followed by 2. If you want to continue, press Y. It's time to view the score of the 3 students. So it will display all of the results of these students very clearly and individually. We want to compare the scores between students from different groups. So if you pick 3, so now it will display all the score from the lowest to the highest. So it will do the bubble sort technique and arrange all of them in order from lowest to highest. So if we don't want to continue, just press anything other than Y. So in my case, I will press N, which symbolizes no. Lastly, it will show thank you for using our grading system. And that is the end of our program. Now I want to explain about how our text file handling perform. So let's say we have 3 students per group. We enter 3, and right now we want to enter the metric number of student 1 in that group. So how do we do that? To do that, we need to refer to the text file for their metric number. So here is the text file. Let's say 3 students. I will give an example like Omar, Ong Chujin, and Hui Jingmin. They are of the same group. We enter the metric number of these students. And now we have moved all of the metric number to this program. Let's say they get 5, 4, 3, 2, and 1 for each of the aspect assignment. After pressing Y, our program continues and we return to our text file. The scores have changed to 5, 4, 3, 2, and 1 for all 3 of these members of the group. How it works is that our program will search for the matching metric number, and if the metric number matches, then the program will key in all the scores according to different position of these scores. The view scores function and the compare scores function, they both work about the same as the key in scores function, but in the opposite way, where they read from the text file instead of writing into the text file.
Alright, so now we're back in round 2. So now let's see what happens when we try to key in number 1 again. Let's say you're accessing it on another day. So let's see what happens. Alright, welcome back, and please enter your username. So let me just put... Alright, so you are successfully logged in, and press any key to continue. Alright, so now let's move on to the part where we all look at the statistical analysis of the data. Alright, so let's key in number 3 for this time. So do you want to check individual results? So like for example, your student checking on your results for the first time, you'll press 1. So I've keyed in randomly all the student marks, so all the assignments marks will be random over here. So because there's 2 assignments, we will now access Dr. Hana's assignment or this current assignment. And then let's say you want to key in your metric number, which is my metric number. And so let's say I got a 44 randomly generated. And also the second semester assignment results is C. So hopefully that's not the case. So let's press any key to continue. And now let's look at the next part of the thing. Alright, so next up we have access assignment data. And then we will check the statistics this time. So now we look at the grade distribution of the class, how many people got A, how many percentages of people got B and C, and so on. So when you click 1, you see which assignment you'd like to check. So let's say we'll check the first assignment, and you can see that this is the data for this assignment. So for A, they got 6.42%, for A, 15.1%, 5% got A minus, so on and so forth. So now for the third part, we will now currently check on the assignment data for checking statistics. And the third part is to compare last semester's assignment and this semester's assignment for the first assignment. So because I'm going to put in Dr. Hana's one, so it's the first assignment. So which student you want to compare? Let's compare mine. I think it will be... So the student's grades has deteriorated by 6 grades compared to the last semester. So now we know that this semester I got a C. So last semester I got an A, so I have actually deteriorated by 6 grades. Alright, so now let's look at the last one. So let's just key in the data and we check statistics. So we key in number 4 this time. So this actually compares your assignment for the second semester and also Puan Maziani's assignment, which we might come in handy in the future. So which student do you want to check? So let's say I'll check my one. So the student did better in their first assignment by 6 grades. That means I did better in the first assignment of SEM 2 than the second semester of SEM 2, because I don't think we keyed in results for that. So it says as such. Alright, so this will mark the end for my part, and thanks for watching. Bye bye.